Hi, welcome to another EPSY for AD video. So today I'm going to show you guys how to perform one sample t-test using Excel. The current Excel version does not provide one sample t-test statistic, so we will have to write the formula ourselves. So let's look at the question setting. You will be able to find this small data sample set right up on the Moodle, and you should follow this example when you're doing your homework right up. So in this example, we're looking at 20 data points collected from a psychological test whether swearing words is going to help you in doing pain better. If you don't remember, 20 participants plunge their heads in the icy water. 10 of them are allowed to swear, and another 10 of them are not allowed to swear. So we are dealing with the question, if they are allowed to swear, will they be able to keep their hands in the icy water for a longer period of time? And last time we have computed the sample means and the sample standard deviation for this two groups, and by eyeballing them we will say that, hey, it looks like if the participants are allowed to swear, they will be able to keep their hands in the icy water for a longer period of time. But it also seems that the variation between the group members are a lot larger than the group that are not allowed to swear. So in the end, we won't be able to make a very clear conclusion whether cursing, whether swearing is actually going to help you endure the pain. In particularly, in this question, we want to answer if swearing words in general will this help the participant to keep their hands in the icy water for longer than for an amount of time that's different than 57.82. Different because we're doing a two-tile test. If it's longer, we're doing a one-tile test, which is on the right-hand side. And if it's less, we're also doing a one-tile test, and the tile is going to be on your left. And I wish you can figure out why by yourself, because you should know when should we do one-tile test and when should we do two-tile test, right? Okay, so let's go get down to business. The question is whether they will be able to keep their hands in icy water for 57 seconds or so, or is the group mean different? So what we are doing here is actually two one sample t-tests. Why are we doing t-tests here? Because we don't know the population variance, right? So we have to estimate the population variance with the sample variance, and that's why we're doing a t-test. And if you don't know why, go back to the earlier material of this weekend review. Okay, so what we're doing here is two one sample t-tests for the first group and then for the second group. Okay, let's do the first group first. Obvi. Alright, so the t-test formula looks like this. We're going to subtract the assume population mean for the sample mean, and then we're going to divide that by the estimation standard variance, which is the sample standard deviation, sample standard deviation over the square root of sample size. Okay, so last time we already get the sample means and sample standard deviation. This is going to be quick. We write down the equal to, and then this is the sample mean, subtract 55.82 seconds, and sometimes I'm not quite sure what Excel does, so just to make sure, I'm going to put a bracket over this value, and then divided that with my sample standard deviation. Again, sometimes I'm not sure what Excel is doing, so it's always safe to put a bracket. Square root of my sample size is 10. So this should give me my t-test, t-score or t-value or whatever. Okay, so we get a t-value which is equal to 1.5 something, right? But we do not know whether this is significant. How do we know whether this is significant or not? One way to find out is that we have to know the critical value. And how do we find the critical value? It's easy. We're typing equal and t-disk, and we know that our t-values is okay, actually that's not the function we need. We actually need t inverse. The probability that we're using here is 0.05, and the degree of freedom is n minus 1, which is 9. And then critical value should be, for some reason this does not look okay. Okay, maybe I need to tell. Maybe I need to tell. Okay. Okay, so let me start all over again. All right. So how do I find this critical value? I put a equal to, and then I put t inverse. Since I'm doing a two-tail task, I have to type in 2t, and then my probability is 0.05, which is the alpha value that I'm using. My degree of freedom is 9 because my sample size is n. Okay, so this is my critical value. So now our test value, our t value is less than our critical value. So in this case, we won't be able to reject the null hypothesis. We won't be able to say for sure that our first group mean is significantly different from this number. Okay? And how do we find the p-value for this t statistic? Okay, so in order to use Excel, we need to turn some tricks, and we need to understand what is p-value and what does the Excel formula usually return to us. So in order to show you that, let's look at a graph. Let's look at a graph. So assume that this is our t distribution. We know that it's symmetrical, and it can be normal looking if we have a sample size that's larger than 30, right? So our t statistic, which we have just computed, is here, right? Assume that it's 1.5 something. It's supposed to be here. And the p-value that we want should be here. The area under this curve, right? Because p-value means the chances of getting this observation or something that's more extreme. So by default, it's to your right-hand side. It's the area to your right-hand side. Right? But if when we are using Excel to find the accumulative probability, it's always going to return the probability to our left hand side, right? So in a two-tail test, we want the combined area, which is here, right? We want, because t distribution is symmetrical, we're actually looking for the combined area of these two shaded areas. So how do we do that? And right, we know that Excel always give us whatever that's to the left, right? So this t value should be, because I also know that the whole area under the curve is going to be 1, right? And then we're going to use 1 subtracting for my t distribution. My t statistic is this. My degree of freedom is 9. Do I want a cumulative distribution? Yes, I do. And then this value have to multiply it by 2, and this should be my t my p-value for this t-statistic in the two-tailed test, right? So we have to turn a few tricks in order to get that. But we can also simply write down a t-distribution for a two-tailed test, and this will also return to us the p-value that we just found. See, it's going to return to us exactly the same value. All right, so let's do the t-test. So our p-value that we just found for this t-statistic is 0.16, which is larger than 0.05. So this p-value should be correct because it's larger than 0.05, means that we will fail to reject our null hypothesis. Okay, so let's repeat the same procedure and let's do the same one sample t-test for neutral word group, this group. Okay, so the t-statistic will be the sample mean subtracting the assumed population mean, which is 57.82 again. And just to be more secure, I'm gonna put a bracket around this quantity, and then my sample center variance divided by the square root of my sample size. And my t value should be minus 0.45. So this t value is somewhere here, right? It's somewhere here. Okay. Okay, so how do I find how do I decide whether I should reject the null hypothesis? I can simply look at the absolute value because t distribution is symmetrical, and compare the absolute value of the t statistic to my critical value. Apparently, this is smaller. So again, I failed to reject my null hypothesis. I do not know. I don't have enough evidence to say that my group mean is significantly different for my assumed population mean. We cannot reject our null hypothesis. So let's find the p-value for this test statistic. Okay, equal to t inverse right, I am looking for the p-value. Therefore, I should use t dis and then degree of freedom is 9, accumulative 2. Oh, okay, let me start over again. So I just show we've just why am I stumbling over myself so much? So we know that the when t is equal to minus 0.4, it's somewhere here, right? So whenever we are looking for the p-value, if we're using Excel, it's always going to return the value to the left, right? But p-value is the chances of observing something that's that is like our sample, or something that's more extreme, which is to our right, right? To the right of the whatever that this vertical line that we found, right? And then in order to do that, we will have to turn another trick. We will have to say, we will have to use 1 to subtract the t distribution that we have with degree of freedom of 9. And So this should be the p-value of this guy. Or if you cross-reference with what we have just computed here with the R software report, you're going to find that the results are the same. All right, I hope you guys find this helpful, and also hope that this is going to help you verify your result of your homework write-up before you turn it in. Okay, see you in the next video.